Welcome to the pre-algebra week of September 22nd. We are in week 6, so that is the assignments that you are going to complete this week are all the week 6 assignments. Before we get to the concepts you're going to cover this week, I wanted to review some of the concepts you learned last week involving parallel lines and a transversal. So you can see that I've got a figure with two parallel lines. A and B are parallel lines, and then there is a transversal line that comes in and intersects those two parallel lines and creates a bunch of angles. And you need to first find the measurement of angle 4. So you are going to use what you know about the patterns that occur to find the measurement of angle 4 for number 1. And then you're also going to find the missing measurement of angle 8. So go ahead and make sure you've got your math notebook out, and I'd like you to try these two problems in your math notebook. Go ahead and click pause, and then when you're ready to check your work with mine, go ahead and click play. All right, so for the warm-up question, we are first asked to find the missing measurement of angle 4, which I've marked on the figure to the right. How can we figure out what the measurement of angle 4 is? So note we do have an angle that is marked. So this angle right here is 75 degrees. Now what are angles, we're going to call that one that's marked already, we'll call that angle 1. So angle 1 and angle 4, is that a special angle pair? It is. So we know that angle 1 and angle 4, so note that I marked in angle 1 there. Angle 1 and angle 4 are vertical angles. And what do we know about vertical angles? What did we learn about vertical angles? We learned that they're congruent last week. We learned that they're congruent. So if we know that angle 1 and angle 4 are vertical angles and thus congruent, we're able to identify the missing measurement of angle 4. That would also have to be 75 degrees. So make sure you have the y in there in terms of explaining why we know that angle 4 is 75 degrees. And the reason why is that we know angle 1 and 4 are vertical angles. And thus, angle 1 and 4 are congruent, and therefore angle 4 would also have to be 75 degrees. Alrighty, let's look at question number 2. It says, what is the measurement of angle 8? Well, angle 8 is down here. And what do we know about, I'm going to go ahead and erase what we did up here. What do we know about the angle pair of angle 1 and 8? So remember, angle 1 is that angle that's has that measurement of 75 degrees that is labeled. So angles 1 and 8, what type of pair of angles are angle 1 and 8? So remember, we always like to look in reference to our transversal. So they're on opposite sides of the transversal, so we call that alternate. So we would say that these are alternate, and then are they on the interior or are they on the exterior of our two parallel lines? So our two parallel lines are right here, and are the angles, the pair that we're looking at, are they on the inside or outside? Are they on the interior or exterior? They're on the exterior, so we would call these alternate exterior angles. And we're talking about angles 1 and angle 8. And what do we know about alternate interior angles? We know that they are congruent. We know that alternate interior angles are congruent. Therefore, we know that the measurement of angle 1 is going to be congruent to the measurement of angle 8. And we know that the measurement of angle 1 is 75 degrees. Therefore, what do we know about the measurement of angle 8? It also has to be 75 degrees. So again, we are taking time to not only state what the missing measurement is, but back up our answer and give evidence of how we are able to figure that out. Alrighty, just reminders to check your grades, see how you're doing overall in the class, making sure you're taking time to see how you did on individual assignments and actually clicking on the assignments to open up and see what you've missed, read my feedback, and then a reminder that you do need to submit, if you submit late work or redos, you do need to email me, so don't forget that. And then just a heads up, if you're submitting late work or redos, it does take me a little bit longer to grade those assignments, a little bit longer than me grading the current work. So my priority is to grade all the current work, and then I start grading the redos and the late assignments. So if you turn late work in late, do be patient. The best way to get your work back in the most timely manner is just to make sure you get your work in on time. Alrighty, so this week you're going to complete Unit 2 session, oops, it's not session 2, it's actually session 3. We did session 2 last week. And you're going to complete the Unit 2 session 1 through 3 quiz. So the quiz, you're going to complete a quiz this week that covers sessions 1 through 3. And you're going to do, before that, you're going to do a little reflection assignment where you're going to take some time to look at the concepts you've covered and see if you can come up with kind of the big idea for sessions 1 through 3. All right, so some things I want to point out as you start working on this week's assignment. It's in Unit 2, Session 3. So you're going to be looking at a lot of the patterns that occur between angles of triangles. So the first thing that you need to know is that when you add all the angles up in a triangle, when you add all the angles up, no matter what type of triangle, how big or how small, you're always going to find that there's a sum of 180 degrees within all the interior angles of a triangle. So anytime you're working with a triangle, if you add all the interior angles up, you're always going to get a sum of 180. So let's use that key idea and apply it to this problem here. So there's a diagram of a triangle with two angles that have labeled angle measurements, and you need to find the missing angle measurement of angle C. So how could we do that? Well, we know that if we add up all the angle measurements, the two that are given, 34 degrees plus 120 degrees, if we add that, I'm going to call our missing angle X. If we add those together, we should get a sum of 180 degrees. So let's go ahead and do the math now. So 34 plus 120, and we get 154. Add that to X, that gives us 180. Then to solve for X, we're solving for an unknown variable. We know we need to subtract 154 from both sides. 154 was positive, so to do the opposite, we need to subtract it from both sides. And then when we take 180 and subtract 154, we get 26 degrees. So our missing angle measurement of angle 4 would be, whoops, I don't know why I put that in there, 26 degrees, 26 degrees. Okay, moving right along. I wanted to review the special notation that we see a lot for right angles. A lot of time in triangles, you'll see this little square in the corner of two sides when they come together. That little square represents a 90 degree So just want you to know that as you're working this week, anytime you see that little square ever in a corner of a triangle, that just represents 90 degrees. A lot of times, and most times, they're not gonna label it as 90 degrees, but when you see that square, you should know that that represents 90 degrees. All right, so isosceles and equilateral triangles. Let's look at the angles that occur between these types of triangles. So the first type of triangle I want to look at is isosceles triangles, and I know we've talked about these in the past and you've seen that. An isosceles triangle has two sides that are congruent. That means they have two sides that have the same length. These little ticks, see how there's a little tick on this side and then there's one little tick on that side? That is a way to show that those two sides are congruent. So that notation there, that tick, the fact that there's one little tick on one side and the one little tick on the other side, lets us know that these two sides are congruent. Just those two sides are congruent. So just these two sides are congruent. This bottom side right here doesn't have a tick in it. So that means that this side length of that triangle is not congruent to the other two sides that are congruent. And what is also true is that when you have in an isosceles triangles, when you have two sides that are congruent, it also means that you're going to have two angle measurements that are also congruent. So I put in one arc and one arc on the other angle, so there's two different arcs there. And since there's just one arc, that means that those two angle measurements are congruent. So this angle measurement is going to be congruent to this angle measurement. Now you note up here there's no arc, and that's because this angle measurement will not be congruent to these two. So this is a special pattern that occurs for isosceles triangles. When you have two sides that are congruent, the sides opposite those, or I'm sorry, the angles opposite the congruent sides are going to be congruent. Now let's talk about equilateral triangles. So an equilateral triangle has three sides that are congruent, and we know that by looking at this diagram because each side has one little tick in it, which lets us know that those sides are congruent with one another. And then you'll note that an equilateral triangle also has all three angles are going to be congruent. And we can see that because each angle has one little arc in it, letting us know that all three angles are congruent. All three angles are congruent. All right, so let's take those key concepts and apply those now. So here we've got what type of triangle? So let's just look at the triangle. So what kind of triangle is this? Is it equilateral? Is it isosceles? Is it scalene? So what do we know about this side and this side of the triangle? What do we know about these two sides of the triangle? These two sides of this triangle are congruent, and we know that because each side has one little tick in it. Notice that this longer side, our hypotenuse down here, the longest side of our triangle, doesn't have a tick in it anywhere. And that's because this side length is not equal to the other two. So because we have two side lengths that are congruent, we will call this an isosceles triangle. So we know, whoops, spelled that a little wrong. We know that this is an isosceles triangle. And we need to find the value of x. We need to find the value of x. And x is representing two of these angles that make up this triangle. Now, what did we learn about the total sum of degrees in a triangle? We know that every triangle has a sum of 180 degrees. So let's write an equation that represents that. So we know if we add our unknown angle plus that other unknown angle plus 120 degrees of this angle, which is labeled, we should get a sum of 180 degrees. Now let's learn the concepts. Let's keep continuing with what we learned in Unit 1 to solve for a missing variable or for a variable. We need to combine our like terms. So we've got two x terms, which means those are like terms, so I can go ahead and add those together. An x plus an x would give us two x's plus 120 equals 180. Now remember, the first step from here to get our x variable all alone is to remove the constant from the left side of the equation. So since 120 is our constant and it's being added, we want to do the opposite. So we're going to subtract 120 from each side. Now we're left with 2x on the left side. 180 minus 120 is 60 degrees. And now we need to solve for x by dividing each side by 2. So we look to see what's being done to x. It's being multiplied by 2, and we need to do the opposite to solve for x. So we're going to divide each side by 2. 60 divided by 2 is 30. So the x represents 30 degrees. And you can check your work. If you add 30 plus 120, do you get 180? 30 plus 30 is 60. Plus 120 is 180, so we knew we did that problem properly. Alrighty, so let's move on to the last key concept that you're going to learn about in Unit 2, Session 3 is the exterior angle measurement of a triangle. So we see that word exterior. So exterior means the outside of a triangle. So if you look over here, this angle Z is on the outside of that triangle. Therefore, it's an exterior angle. Exterior angle. And there's actually a pattern that occurs with the exterior angle and then the two non-adjacent interior angles. If we add these two angles that are opposite of that exterior angle, if we add those two up, they're going to equal the measurement. So if we add these two exterior angles up, they're going to equal the measurement of the exterior. So we're going to add the interior. I think I was saying exterior. If we add the interior angles, we're going to get the measurement of the exterior. Now it's important to note that it says the two interior measurements that are non-adjacent to the exterior. So remember, adjacent means that there are two angles that are right next to each other and share a vertex. So the angle that is adjacent to angle Z would be this angle right here. So let me get my little pointer going again. So angle Z would be adjacent to this angle right here. Now we're not going to use that because we want to find the sum of two non-adjacent angles. So we want to use the two interior angles that are non-adjacent to that exterior angle. So when we add the two interior that are non-adjacent, we're going to get that measurement of the exterior angle. So let's apply that now to this question below. Solve for x. So x represents an exterior angle. We're outside of the triangle. How can we find that? How can we find that? And I'm going to throw in an angle measurement here. Whoops. No, I'm not going to. So remember, we want to use the two angles. So we've got, this is our exterior angle, exterior. We want the two interior that are non-adjacent to that. So we would take 36 plus 72, and that's going to give us the measurement of our exterior angle. So 36 plus 72 is 108 degrees. And that'd be our total, that would be our answer. So you'll get to practice this week. And that brings us to the end of today's recording, and you guys are ready for your key phrase assignment. I'm going to draw a diagram up here of a triangle that includes an exterior angle. And I'm going to label all the angles that occur. So we'll call this angle 1, angle 2, angle 3, and angle 4. So if I wanted you to find the measurement of angle 4, what two angles would you add together? So to find the measurement of angle 4, what two angles will you add together? So this is all about the exterior angle theorem that we just talked about. And just tell me the numbers. Which two angles will you add together? And once you are done with, make sure you complete this key phrase assignment to get your credit for watching this recording. And that's it. Have a great rest of your week, and remember to ask me questions if you have any.